Okay, here's example 10 from the packet that we started today. It is without a diagram, as you can see, so it's kind of new and a little bit different. I'm trying to get that to focus. It doesn't look like it's focused the best. So anyhow, we have to draw our own diagram as we read through this. This is kind of a level up from the ones that we were doing in class. There's a couple more added steps and a little bit different way that we do it. So I expect that you're copying this onto your packet, not just watching the video. Pause it, rewind if you're confused, okay? So water runs into a conical tank at the rate of 9 cubic feet. This is interesting to me because it's going to help me write my given per minute. The tank stands point down and has a height of 10 feet and a base radius of 5 feet. So these numbers here are just helping me to draw the diagram for this problem. It says, how fast is the water level rising when the water is 6 feet deep? Okay, so my given information, since I read the word rate here and it says cubic feet, I'm going to call that my dV dt is equal to 9 cubic feet per minute. Okay. And then it says that it's running into the tank, so that's why I made it positive. Some of these problems will have water leaking out of something, and if that's the case, you're going to want to say that it is negative. Okay, so we've got a drawing now I can add in as I read through the second sentence. So I have a conical tank and its point is down. So we basically need to draw a cone. Okay, and in this cone I'm going to label the height 10 feet. So from a point in the center of its base down here, this is 10 feet. And then from here outward, my radius is 5 feet. A lot of times they try to trick you by giving the diameter too, so make sure you label it appropriately. It says, how fast is the water level rising when the water is 6 feet deep? So we're talking about how full this tank is, right? So I'm trying to find, and for cones, we typically use the variable h to represent the height of the cone, right? That's what we refer to when we talk about the water level. So we're finding dh dt, and since it says when the water is 6 feet deep, that's again referencing the height of the water, so I'm going to say at h equals 6, okay? So as I start to write my equation for this, like I have in the past, I'm going to kind of note these two variables. So notice I have a v and an h, so I need a volume for a cone, right, that is made up of h, okay? Well, the standard volume formula that I think you're used to, right, is got a radius in it. Okay, so I'm going to start with that. Okay, 1/3 pi r squared h. That's the standard volume of a cone. Okay, this isn't really going to help us in this problem because I don't have any information about dr dt. Okay, notice this r here. That's not in my given. It's not in my find. So I'm going to have to weed that out somehow. Okay, and I'm actually going to do that before I differentiate this. Okay, and it's going to come from over here in my drawing. Okay, it turns out, right, that I have similar triangles within any cone. So this green triangle, right, is similar to the blue triangle that I have already sketched here, this guy. Okay, and so this is my radius and this is my height. These are always proportional to one another, right? So if I set this up, I could get 10 is to h, right, is 5 is to r. Cross multiply, you could set this proportion up in like 100 different ways. And I'm going to go ahead and solve for r by dividing by 10. So I get 5/10 h, but that's better known as h over 2, right? 1/2 the height this way, okay? So you can read that right from here, right? You can see that the radius is half of the height, okay? So you could just input it from there too. But I'm going to sub out that r with that equality first. Okay, so here I'm subbing out the r, okay, using my relationship from over here that we discovered. Okay, and then once I do that, I'm going to go ahead now and simplify this a little bit before I differentiate. It's not going to help to do the derivative in this form. So I'm going to write v equals, see if you follow this with me. I'm going to put the pi in the numerator of the fraction 12th, right, and then I'll have h cubed. Do you see that from here to here, right? H squared, 2 squared, that's 4, times this 3 is how I get a denominator of 12. Okay, and at this point now, I'm ready to go ahead and take the derivative with respect to time. When I do that, right, I get dv dt equals, and just do the power rule over here, right? 3 pi over 12, if I bring the 3 down, but that simplifies to pi fourths. H squared, here's the implicit portion, right, times dH dt. Okay, and now I'm going to sub in, once I differentiate it, I can put in the values from up above. My dV dt, it was determined earlier, was 9. Pi fourths is a constant. The height in this problem is 6. And dH dt is my variable. That's my find. So I'm going to leave that as is. Okay, I'm going to simplify this. I get 9 equal to pi. Actually, 36 divided by 4 is 9. So it's 9 equal to 9 pi times dH dt. So I'm going to divide both sides by 9 pi. And please make sure that you write down that 9 divided by 9 pi is 1 over pi. They have a lot of students simplify phrases like that incorrectly, and that makes me nervous. So I've got 1 over pi. I'm going to leave room for my units, right, equal to dH dt. So height in this problem is measured in feet, and time in this problem is measured in minutes. Okay? So that's example 10. What I do want you to do is to try example 7 now. It's very similar. We've got a picture of a cone, way better than I drew it, right? Look at that, it's gorgeous. Okay, we've got this relationship between the radius and the height. And then the only kind of quirk in this one is it gives you the rate in gallons per minute, and it gives you this equivalency. So right now we're just going to transfer this gallons per minute to cubic feet per minute, and that would be just multiplying these two. So it's 1.337 cubic feet per minute. That's how you'll want to understand that given. Okay? So write your given, write your find, sub out any variables you don't need, differentiate, and see if you can get an answer. Okay? Go ahead, pause the video now, work on that, and then I'll kind of give you the answer in a sec. So go ahead, hit pause. Okay? Coming back, after that, the answer you should have, I have an answer that's correct to 3 decimals, right, because of this. Your dH dt should be 0.189 feet per minute. Okay, so 0.189 feet per minute for your dH dt. Okay, kind of try to work on that again if you didn't get it.